Beautiful. Hello.
Hello.
To all of this is FACE AICTE program, pre-training program. Like 10:30 to 12:30 and noon session 2 to 4 p.m. So the topic is for today, day 2, natural language processing. And also afternoon session, the demonstration and hands-on session on natural language processing by our honorable resource person, Dr. Lakshmi B. Rananware. So Associate Professor, School of Computer Science and Engineering, Reva University, Bangalore. So, Madam is with us. We heartily welcome to our Madam Honorable Resource Person, Dr. Lakshmi B. Rananware. So, I welcome you, Madam, from on behalf of SITAM, and we welcome from the department as well as SITAM Engineering College. So, I request to honor you. So, Saranya and as Mohan will do and take further Saranya, please.
Good morning, everyone. We are happy to invite Dr. B.R. Lakshmi, Associate Professor as part of AICTE STTP on the topic Machine Learning using Python and TensorFlow on behalf of SITAMS College. Her qualifications are: she received BE degree in Computer Science and Engineering from Karnataka University, CDAC Bangalore, MTech degree in Computer Science and Engineering from Vishweshwaran Technological University, PhD degree in Artificial Intelligence and SV University College of Engineering, SV University Tirupati. She is currently working as an associate professor in the Department of Computer Science and Engineering, Reva University, Bangalore, India. She is life member of CSI, life member of ISTE, member of IEEE India. She has more than 26 years of teaching experience. Remaining details will be read out by my friend Mohana Priya, 3rd CSA.
Her areas of research interest are artificial intelligence, machine learning techniques, algorithms, neural network, and fuzzy applications for software engineering and testing. She published 8 papers in international journals. She published 6 papers in international conferences. She guided 8 PG projects. She attended 7 conferences and seminars. She conducted 22 workshops and 5 conferences. Now, we are requesting Dr. B.R. Lakshmi Garu to take over the session.
Thank you, madam. Thank you.
Thank you, Saranya. So, and Mohan, please take over the session.
Okay, sir. Okay, sir. Am I audible? Yes, sir. Am I audible, sir?
Audible.
Yes.
Audible, madam.
Yes, sir. So I would like to start with this NLP. NLP stands for Natural Language Processing. And there's a lot of work, and it is a branch of artificial intelligence. It is quite different from, you can say it is different from data mining or web mining in some sense, because there is a intelligence hidden in natural language processing. And that's why it is more other to the artificial intelligence as a such. So I would like to talk on what is the role of Indian languages in natural language processing in morning session. And in the afternoon, I would like to talk about a demo on how the natural language processing is being done. So that I'm going to talk in the afternoon. So I would like to start with this. In the context of Indian vernacular languages, we have we are going to see the need for natural language processing, applications of natural language processing, and what are the challenges and resources where we can find the text for processing. So we can see this. We have in the Indian map. We can see depending on the geographical locations, we have different languages which are spoken and written in India. So let us say in Kashmiri, they are going to talk Kashmiri. In Punjab, they are going to talk Punjabi. And in Madhya Pradesh and all, they are going to, their native language is Hindi. In Maharashtra, it is Marathi. In Andhra Pradesh, it is Telugu. In Karnataka, it is Kannada. And in coastal areas, it is Konkani. And in the Tamil Nadu, Tamil. And in Kerala, it is Malayalam. So there are so many languages we have in India. And the major languages, India is a multilingual country. So we have 22 major languages which are written, which are spoken by different people, as well as and out of these 13 have different scripts. And there are again from time to time and from place to place in the geographic locations in India, there are different dialects also. It crosses 720 dialects we are going to have in India itself. So suppose if I'm going to say in Kannada, in my native place is quite different than whatever we speak in Bangalore. Similarly, it may be true for other states also. So dialects are different. So over 720 dialects we have in Indian languages. And there are 5 Indian languages which are extinct. Some of the languages which are now in the verge of extinct. In the spoken language in Himalayan belt, these are and Oham, Andhro, Ragkras, and Tolcha. These are the Indian languages which are spoken in Himalayan belt like Assam and all. These languages are becoming extinct. So language plays very important because it shows our culture. So we have a variety of culture which is exhibited in our language, and India has a rich culture, and we should preserve this culture so that we have variety in our country, and that should be preserved through the language. And there are almost the Indians speak more than 780 different languages. Even in state-wise also, the people will be having like suppose Kannada, Telugu medium as well as English medium and medium. So suppose a person is studying in Telugu medium, he is learning English also as a second language. So in the Indian schools, not only one language will be taught. It is taught in depending on the state. It is they are going to learn one or two different languages in their school, and this is very important because whenever we think in our mother tongue, and when you study in mother tongue, you are going to understand in way. And that's why when there are so many languages, we should know how it can be processed by the machine. So that we are going to look into. Look into in today's talk. So, natural language processing, it is an interdisciplinary field that deals with interaction with computers and humans using the natural language. So, what we speak is a natural language. What human beings speak is a natural language. It may be any language, Kannada, Hindi, Telugu, any language, but it is the human beings can use the language to communicate with each other. and that is called natural language. And when we program on the system, it is a computer language. So computer language is different and natural language is different. Natural language is used by the human beings to interact or to communicate with each other. And this language cannot be understood by the machines or computers. And how we are going to process, that is a technique. There are several techniques wherein we are going to see today's talk. So we should make the computer to understand what we talk, or what the natural language should be made to understand. The computer should made to understand a natural language. Okay, so when the way the computers can analyze, understand, and derive the meaning from the human language in useful and smart way. So natural language, how to process natural language, we are going to see uh, uh, by the machines. Okay, so the need for natural language processing. So most of the Indians are multilingual. Even in Andhra, they'll be knowing, in Hyderabad zone, they'll be knowing Telugu also, they will be knowing Urdu also. So most of the Indians are multilingual, and they know more than one language in the school. So the percentage of English speakers are very less in India, just it is 10%. And that means most of the people cannot, because all the programs which are written on the computers are using English language, but to make to understand other than English language is quite difficult. So we cannot process our language on the machines. So percentage of English speakers is very less, and most of us, we cannot communicate with the machines. So most of the Indians are having Hindi as a first language, and followed by the regional languages. So a lot of people, because lot of people stay in rural areas, and they don't know English at all. They cannot understand, or they cannot speak English. So there should be some way so that we can process the language, the native language which they speak. So the dream of digital India cannot be realized without bringing NLP research and application in India. It should be as strong as English, so that we can efficiently work with the systems, and we can use the language in a smart way. So it is clear for the need. There is a clear need for NLP research for Indian languages. So when the people do not know English, they can get online information in their native language. That is the true sense of the word. So through India, though India is rich in languages, it is poor in resources of these languages, because we do not have digital media or the information, whatever, how to process that. That is, we do not have sufficient resources for processing Indian languages. So applications of natural language is smartphones, because India, in India, many like there are more than 500 million users are there, smartphone users are there in India. That is crossed, almost it is crossed in 2019 itself. So many people use smartphones in India. It is one of the most widely, after China, most of the people use the smartphones are used in India a lot. And digitalization of Indian manuscripts. So each language has got its power. Each language has got its knowledge which is hidden in that language. Each language has its culture. Each language has its different techniques to understand different geographical strengths of maybe it is a earth, or maybe it is farming or anything like that. So you can get the knowledge from this. We can get the knowledge from the language, and digitalization of Indian language is very important. So even when we see on the most of the languages should be available in a digital form. That means instead of having that information on the paper, we should have that information on the digital. That is possible through the internet. We can access that information if it is in a digital form. So we can preserve the knowledge in a digital form, and so that we can understand and make use of systems in a smart way. So and also we have seen there are different, we travel in different geographical areas in the world, and the signboard translation also is one of the, so different areas will be having different signboards on the road, and how you are going to translate that in a particular language, because if the person is traveling in a particular or driving in a particular locality, he may not be knowing the signboards which are there in that area. So how these signboards can be translated? So that is one of the applications we can have for the natural language processing. Also, the fonts in Indian scripts. So we have many scripts, and how we are going to have how you are going to translate these Indian scripts, or how we can understand these Indian scripts is a very important. How we can make these Indian languages for readability of advertisements, signboards, presentations, and reports, so that in the native language, that is one of the application which we can have for the natural language processing. Also, the people who are disabled, disability, the people with disabilities. Sorry. The interpretation of sign languages, like the people who are not able to speak, they use sign languages, and that sign language can be translated using natural language processing techniques. Also, the text to speech. Suppose the person is cannot read the text, that text can be translated into speech. So text to speech, wherein the people who do not are not able to read the particular language, particular script, that can be made translated to speech. So text to speech is one of the application. Also, speech to text is also gaining wide popularity, wherein the speech is translated into text. And when that means instead of writing that, or making you just speak you just speak, and that will be translated into text. So we can when it is been when it is translated, the speech to text, when it is being done, large digital information we can get in a short period of time. So that is the advantage we are going to have with these such kind of applications, which can be built in the native languages. So NLP can go a long way, which a long way by improving the search accuracy. Like how we have in Google Assistant, we have multiple Indian languages can be built using, by writing chat box or virtual agents in the same. How we have in Google Assistant, for if it is possible to have such Google Assistant for Indian languages, it will help a majority of the people who are in the rural area, especially farmers, and they can get the knowledge of whatever is there on the internet, and then thereby they can go far with the knowledge whatever is there on the net. So what are the challenges we are going to have when we are going to think of natural language processing toolkits when we are going to generate? So the expectation is one should have, when you want to process, we should have a corpora. Corpora means a set of documents which we are going to have for processing. So it is a digital information or digital text information that is called corpora, and it is very difficult to find in Indian language. We do not have much of the literature in the corpus form or in digital form. So we should have some technique wherein we can build a corpora for Indian languages, and we should have some tools which can do as good as English language, because English language is widely used throughout the world, and they have whatever we do, whatever we text using WhatsApp or using Twitter or using some web design, all this is done using English language, and thereby it is going to generate large volume of corpus or corpora. That is not there in Indian languages, and this is one of the this is one of the challenge we have in Indian languages. So the problems and issues in specific to the Indian languages, we have a lack of data set or corpora. We do not have much of the e or digital information or text information in digital format. We do not have that, and that is the lack of data set we have for the Indian languages. Also, we have very people, we do not have, we do not, very less efforts have been done by different organizations. Very few, especially I would like to tell, only few universities are having this course on natural language processing, or they teach this topic. And it is quite difficult also to have expertise in these and to develop such kind of expertization. For example, we have natural language processing in especially I think in Andhra, we have many places, they have this course, AI course and natural language processing in Central University, as well as in IIT Bombay. They have the branch on which does research on natural language processing, as well as in Kolkata, CDAC, they work, CDAC in Bangalore as well as Kolkata, they work on natural language processing. CDAC is especially working on more on natural language processing. On they find the tools and techniques for processing the Indian languages, so that in the railway reservation system or any other system that can help the people to have the natural language, so that they can understand and then they can work with that. So we have very less, we have lack of consolidated efforts in with respect to Indian languages. And there are a lot of Indian languages, almost all Indian languages are morphological richer. They are morphological rich languages. Whereas English language is very simple language, and processing English language is quite easier than the Indian languages, and that is the hurdle since it is morphologically rich. All the Indian languages are morphologically rich, and there are variations in morphology, morphological analysis, and thereby Indian languages have the problem of morphological variations. And also there are lack of standards, because we do not have the standards to process these natural Indian natural languages. Also, the online resources to learn natural language processes for processing for Indian languages are limited, and these are which are limited compared to the English language. So these are the problems which we have, and these are the challenges for the Indian languages, which thereby there is a very less research which is going in this area. So the research, resources for this AI for Bharat platform for to accelerate AI innovation in India. So we can go through this GitHub account so that we can find this catalog. Then Indic natural language processing library, we can have this library which is generated by Anup Kunchukuntan. And text mining online, we have these sites which are developed for sentiment analysis and opinion mining. And also we have analytics vidya for school children. So these are the resources which wherein the school children can make use of these websites for learning in their own language. And towards the datascience.com, this is one of the resources which we can go through for natural language processing. And the resources for natural language libraries for Indian languages. So there are Indic library, natural language processing libraries. So the goal of Indic natural language processing library is to build, which is built using Python language, and it has many libraries for text processing. Okay. Also, it uses text processing. It is going to have this NLP library has many processing techniques for Indian languages. So most of the Indian languages are having similarity in terms of scripts, like Hindi and Marathi are having similar scripts. Uh, uh, less all Devanagari scripts, like which are originated from Sanskrit, are called Devanagari scripts, which are having a lot of similarity, like Hindi, Gujarati, Marathi. All these are using the Devanagari scripts. Phonology, we are going to have the similarity in the phonemes. And the language syntax also, if there is a similarity. Even I found that Kannada and Telugu language are having similar script. I can read Telugu, but I cannot understand. So the script similarity is there in most of the Indian languages. So they have a lot of similarity between the different languages. And thereby this NLP library, Indic NLP library, which gives a general solution for wide variety of Indian languages. So the library provides the following functionalities. I would like to tell more about this text normalization in the afternoon section. So how for any processing of text, that text should be normalized. So this library provides this text normalization, whether it is a data, whether it is numeric or text. The data, whenever you are going to process it, it should be normalized. And there are some libraries which performs this text normalization. Then we have script information, how the script should be, how the script is written, and thereby how you are going to translate from one script to another. So that script information library we are going to have for the NLP library for the Indic language. Then how you are going to break the sentences or the document into sentences and words, and that technique is called tokenization. So we have libraries for breaking the large breaking the large document into tokens, and these tokens, maybe it is a sentence or maybe it is a word. So that is called tokenization. So we have word segmentation also. So for Indic language, suppose if I say my college jaungi. So jaungi, when you say jaungi, it has two words in that, ja and ungi. So that word segmentation also should be performed in many of the languages. In Indian languages, word segmentation is must, but that problem is not there with the English language. And that's why processing English language text is quite simpler than the Indian languages. So word segmentation is an important library function we can have in NLP library. And then the Romanization, okay, how the Roman numbers are converted into Indian languages, and how you're going to do Indianized version of the Indian languages that we are going to have as a library in Indian NLP library. Also, transliteration and translation. Translation means from one language to another language, we are going to translate completely from English to, say, Hindi. So that is called translation. So for that also, we are going to have some libraries which can be used for performing these operations. So NLP libraries for Indian languages, we have a very famous library called NLTK. NLTK stands for Natural Language Toolkit. Yeah, Natural Language Toolkit. And this NLTK is built by Stanford University. And this Stanford University, they are working on NLTK from past 30 years. And they have this NLTK which is built on different languages all over the world. You can have NLTK for English, obviously it will be there, then Chinese language, and also it is having supporting languages for the Indian languages like Hindi, Punjabi, Sanskrit, Gujarati, Kannada, Malayalam, Nepali, Odia, then Marathi, Bengali, Tamil, Urdu, English. So it supports all these different languages. NLTK has got different libraries which are present in this module. So that using NLTK module, we can process any Indian languages. The thing, when you have this toolkit, we can build the corpus and we can work with the corpus in our native language. Okay, so there are some more NLP libraries, Python libraries, which we are going to have. That is NLTK. It is the famous Python library, NLP library, and so it has conquered all other toolkits which we have at present. And also we have some other libraries, NLP libraries, which are built using Python, which can be used in Python language, that is text block, and this is also text processing, which we can use for as a interface to NLTK. Also, we have mercenary Stanford Core NLP. So Core NLP is a natural language analysis tool, which includes many libraries like parts of speech library, tagging, parts of speech in the sense any sentence in any language, we have words which are going to we are going to combine these words and to form a sentence, and these words are having different parts of speech. Okay, so say noun, verb, adverb, all these are parts of speech for English language. So which includes these parts of speech. And this core NLP, which is built by Stanford University, has it includes parts of speech that is it is also called pause tagging. Okay, so for each word we are going to tag. Say if I'm saying college is a noun. So noun is a tag which you are going to give to the college. Okay, so different words are given different tagging. For each word we have to tag so that we can separate what are the different types of words which we are going to have to understand the sentence in a better fashion. So part of speech which will help us to understand the language. Also the entity recognition. Suppose if I say SITAM Engineering College, Okay, engineering college, we know that these are the entities, or suppose this SITAM is a name which is not present in any of the dictionary. So we should see that how we are going to have how we are going to understand that this is the name of the organization, and this is not a word which is stored in any dictionary. So that is called named entity recognition. It is also called entity recognition. So named entity recognition, because it is also important that depending on the context, we have to understand what are the named entities which are present in that sentence. So they have the library to find the named entity recognition. Again, this is a wide area which can be done with a lot of algorithms can be written on named entity recognition. Also, pattern learning. Like when we see an object, what we are going to see, when we see the object, that pattern will be stored in our mind, in our brain. And when we say that, suppose you are showing a particular object to a child, say ball, you are showing that ball and you are uttering that word, and thereby the ball is the word which is being stored in the child's brain, so that whenever that ball is shown to him, he is going to utter the word ball. Okay, so that pattern, all these words are having the pattern, and that pattern will be stored in the brain. And how the machine is going to understand the pattern with respect to different languages words. So that's what is pattern learning. And then when we say a language, the language, whether like how in computer science also, we write a program and that will be compiled. What is what compiler is doing? The compiler is going to pass the program, and it is going to find there are different phases. As you know that there are 7 phases of in compiler, like lexical analysis, semantic analysis, and so on. So there are so many, like how the particular computer language is passed. Similarly, the natural language also should be passed to find the meaning, and to build a tree, and that is called parse tree. So passing is a very important thing, wherein you can understand the chronology, or you can understand the significance of the different parts of the sentence, or different parts of the language, that we are going to look into using this passing. So core NLP is having a very powerful Stanford core NLP parser, which can be used in for different languages. Okay, so there are many this Stanford core NLP, which has many libraries to perform different operations on the text. But the only the thing, first we should have the text or corpus, and thereby we can understand, the machine can understand this text, and it can give a proper proper the application can do a proper work for us. Suppose our ability of reading a textbook, let us say reading a novel, will be limited. But if you ask the machine to read it and summarize it, and text summarize is also a very important task, which is wherein when the machine is going to learn from the text, and is going to give the summary, that is also very important, so that it is going to save our time. So these are the different toolkits which we are going to have for the natural language processing. Also, we have another module called SPACY. Okay, so this is also marketed as a Python NLP library. And another well-organized, optimized library we have, that is called GenSim. About these tools, I'm going to talk in the, I'm going to run the code in the afternoon session, and I'm going to demonstrate this, but only to make the just introduction to these topics I'm just talking here. So GenSim is a optimized library for topic modeling and document similarity analysis, and it is not generally used for NLP, but at least we can see what are the important topics in the text. For that we can use GenSim package. Also document similarity, how the particular document is similar to another document, like plagiarism checking and all such things we can have for using, can be built using this GenSim package. So these packages, these libraries perform a lot of tasks. Okay, so these NLP libraries, as I said, part of speech tagging, sentiment analysis. Part of speech tagging is very important because each word for each word in a particular language should be tagged, whether it is a noun, whether it is a verb, whether it is an adverb, so that we can understand what this text is, the meaning of the text or the sentence we are going to understand using these parts of speech tagging. And then another application, as I discussed, is sentiment analysis. We have a text and we just want to know what is this, what is the sentiment which is hidden behind this text, and that is called sentiment analysis. So that the sentiment analysis packages, also we can write a code for sentiment analysis. Okay, so these Python libraries can be used for sentiment analysis work. Document classification, without reading the large document, we are going to see different documents are fed to the system, and we are going to say what a particular document is all about. We can classify the documents using these libraries. Also topic modeling, which are the important topics, or which actually how you can give a title for a particular document, that also can be done in topic modeling. And there are many more Twitter analysis, Facebook analysis, then spam detection. There are many recommendation systems. All these are using these NLP libraries. Okay, so the NLP libraries like NLTK, which is only for education and research tool, and we can use this NLTK library for natural language processing. And then another is text block. Okay, it is built upon this NLTK library module, and which is easily accessible. And whenever you want to have a optimized performance, then we can make use of this text block. Then next one is Stanford's core NLP. This is built using Java, and it is used by as a as a Python wrapper. Okay, so Stanford core NLP is built in Java, using Java language, and this can be used in as a Python wrapper. So there are many productions which are using this, production systems are using this core NLP. And so this is all about SPACY and GenSim, which are used for topic modeling and similarity detection. So how we are going to analyze text. So there are three ways of text analysis. Any text, in irrespective of any language, there are actually three methods or ways of doing text analysis. One is vectorization. So the text, why text processing text is quite difficult than processing numbers, actually, because the text, when you process the numeric data processing is quite different than text data processing. And because numeric data processing, we have numbers and we have algorithms which can process on the numeric data, but text is not like that. It has there is no numbers in the text, and that text should be converted into numbers, and that can be stored as a vector. And only then, when the text is stored in a vector format, only then we can process that vector. So vectorization is a very important topic in text analysis, because text as a text we cannot process it. It should be, for each word we should have a particular number, or we should have some information other to that word, and only then we can, in a number form, so only then we can process that. Because computer is a number crunching machine, it cannot process the text information. Only when you translate these words into vectors, then only we can process the text. Okay. And also the another thing is, pre-processing is very important. Whenever you are going to process text, some of the pre-processing is very much necessary. Because suppose, let us consider that we are analyzing Twitter information. So Twitter information or email information are having some special characters which are used, like at symbol, hash symbol, or some emojis. Okay, some smileys are used, and these should be processed. This should be processed. The meaning of this should be processed, and thereby it is very important, when you are going to process this text, we should understand these different special characters, and whether you want to remove that, or particular information you are going to gather from that, and you are going to place it as a knowledge base. That is all about pre-processing. So suppose if you are going to analyze the email, then you are going to remove this at symbol, because only the text information you want to have, and you should remove special characters in the mail, and thereby that is called pre-processing. So the special processing, some noise will be there in the text, that should be removed before processing, before applying the any algorithm for that text. So pre-processing is also very important in text analysis. And after that, once you pre-process that, and then you're going to apply any machine learning, because machine learning will not directly work on the text. Okay, machine learning algorithm only works with the machine learning algorithms, or statistical algorithms work only with the numbers. And after processing the text, we have the information uh, in a number format, and thereby we can apply machine learning algorithms on these vectors, whatever we have formed. So these are the three very important topics in text analysis. Then coming to the first topic, that is vectorization, word vectorization. So how we are going to map the words or phrases from vocabulary to real numbers. Okay, so let us consider, I go to college. I is one word, second one is go, and third one is college. So these words, we are each one in a particular language will be assigned a unique number or real number. We are going to assign for that, so that we can process those words. So different words or phrases are given different real numbers, which are assigned to these words and phrases for processing. So word vectorization, wherein we are going to assign the numbers to the words or phrases for a particular language. Then that means these words are converted into numbers. Okay, so these vectors, when you convert these words into numbers, and those are stored in an array or vector form for further processing. And now when you say what is vectorization, then these are the words or when you have this word vector, and the machine learning algorithm will work on this uh, we'll work on this text. Okay, so the sequence of characters, how it is should be processed. But the so when we have this vector format, all these columns, let us say we have a matrix form, so these columns, or we can say these columns, are the words and the respective numbers which are stored for these words. So we are going to have the vocabulary for which we are going to have, for each word we are going to have the numbers. Okay, and so machine learning algorithms can be so these words or these features, okay, which are these features can be used by the machine learning algorithms. And these features, you can say that these are the numerical attributes for that language, okay, for that vocabulary. Okay, so we are going to see now there are various techniques of word vectorization. So, so to convert the string, like when you say string, or when you say text, what is text actually? Text is a set of characters. We can have a set of characters, and that too. When you say sentence, sentence is a set of words. Or similarly, we can say it is a text. Text is what? Text is a set of strings. And this string data is converted into numerical data. Now, how we are going to convert to numerical data? So there are various techniques for converting the text data into numeric data. The first one is bag of words. Bag of words, or it is also called one-hot encoding. For each word, uh, for in a particular text, what are the important words? What are the important words which you are going to see? Okay, and that the in the text we are going to see what all different words are there, that we are going to see, and that is called bag of words. That means in this bag of words we are just having the collection of words, but the order is not important here. Okay, and for each word we are going to assign a unique number, so that is called one hot encoding. So bag of word, which is a collection of words. It is just a collection of words, and the words which are the features of that text, or we can say the important words in that text, that we are going to call it as bag of words. Okay, and when you say this bag of words, okay, how many times a particular word is occurring, and that is called frequency weighing. Okay, so frequency weighing, how many times a particular word is, that means how prominent the word is there in that how prominent the word is in that document, that is going to tell about the frequency of the word. And we can also see how many times a particular word is repeated in that text, that is called frequency weighting. And then another technique is called TF-IDF. TF-IDF stands for term frequency and inverse document frequency. So term frequency and inverse document frequency is another uh, way of dividing the text data into numeric data. Okay, so the text or the string data into the numeric data. So what is TF? TF stands for term frequency, and IDF stands for inverse document frequency. And this technique is also used in many of the applications to find how many to see the significance of the particular document in a particular text in the document. So to identify that, this TF-IDF is used in many applications like sentiment analysis, or spam data collections, or in recommendation system, how particular item is more popular than other, how you can make the customers to attract a particular product. So they are going to use this TF-IDF technique. Okay, so it is going to, in this form, the string which is converted into numeric data using TF-IDF. That also I'm going to talk how you're going to convert that in the afternoon session. And also there is another technique of word vectorization is word to vec. So word to vec is wherein the word, all the words in a document are stored in a vector form. So we have a library to do this. So this technique does this word to vector. So this is also called word vectorization. So there are so many different techniques which are used for word vectorization. Once it is done, then the text can be processed using any algorithm, machine learning algorithm. Now let us see a sample corpus. Corpus means what? Some text information. So text information, let us say the corpus is having this information. Say it is written in Python. It is written in Python. So we are going to have um, uh, three sentences. The elephant sneezed at the sight of potatoes. And second sentence is bats can see via echolocation. See bats size sneeze. And third sentence is wondering. She opened the door to the studio. So these are the three sentences which we are having in this corpus. So this corpus is having three sentences, and basically it is represented in you can have a just for simplicity I have taken it as a Python list, but you can have a text file. Okay, so let us consider this corpus is having this. So we are going to have this encoding space. So the first sentence, the elephant sneezed at the sight of potatoes. So all these words are stored in this word to vector. Okay, so all these information will be stored. Okay, so it is going to have a bag of words. So let us consider. So this statement. Okay, so when you have a particular word which is present in that sentence, then it is represented as 1, or else it is represented as 0. So in the first sentence, we do not have at, bat, we have at word. So it is stored as in that cell, we are going to store it as 1. But we do not have bat. In this corpus, we do not, in this sentence, we do not have bat. So it is stored as 0, and can is not there. And similarly, potato is there. So it is going to have 1 in that place. Also, elephant is there, so it is having 1 in that place. And 1 off is there, so it is going to have 1 in that space. And all the other when it is not there, it is going to have 0. When the word is not there, then if the word is present, then we are going to say it is represented as 1. And if it is not there, then we are going to represent it as 0. And this technique is called one-hot encoding. Then we have second sentence wherein bats. So I can see here there are twice this bats word is appearing in this second sentence. So the count for this bat will be 2. Okay, whereas at is appearing only once. So we are going to have at is not appearing in this sentence. So we are going to have 0 in this place. Can, we are going to have 1. Then door is not there in this sentence. So it is going to have 0, and so on. So similarly, for the third sentence, we are going to have, we have wonder. So how many times it has been appearing, okay, the frequency of this, the number of words divided by the word divided, how many times that word is occurring divided by the number of words that we are going to have as a frequency. So we can store in a real form also. So that's what we are going to have for this TF-IDF representation. For the previous I have for this first one hot encoding, wherein each word, if it is present, we are going to represent as 1, and if it is not present, then we are going to represent as 0 in the vector space. Similarly, for the frequency representation, how many times a particular word is present in that document, that we are going to represent as a frequency number in the vector space. And the third one is TF-IDF representation. In this, what is TF-IDF representation is how many times a particular word, let us consider a word is appearing in a particular sentence. How many times that word is appearing in a particular sentence? How many words are present in that sentence? Okay, the number of times the word is appearing divided by the number of words which are present in that sentence. Okay, and how many times this word is appearing in different documents, that stands for TF-IDF score. So we are going to calculate that TF-IDF score, and it is represented. If it is not if it is not there, if that word is not there, then all other numbers will be filled with zeros. So we have sparse matrix for this. Okay, so these are the different ways of representing word vector or word vectorization. One is one hot encoding, second one is frequency, and third one is TF-IDF representation. Okay, so distributed representation, also we can calculate how much it is dispersed in the space. That also we have built-in function for distributed representation of each document in the corpus. That also we can have in the distributed representation. Then a distributed representation means it is not just a simple mapping. Okay, the resulting document vector is not a simple mapping from token position or token score. Instead of, the document is represented as a feature space. Okay, what is the feature of a particular document that we are going to understand, and it is embedded to represent the word similarity. How a particular word is similar to another document, that we are going to see in the distributed representation. So this word to is created by a team of researchers in Google, Thomas Mikulov, which in this word embedding model, wherein it is a distributed representation, and this is a model which is word2vec is a software, or word2vec is a package which is built by a Google researcher, and which has this word embedding modeling technique. Okay, so another word2vec algorithm which trains the word representation. We are going to see what is this continuous bag of words and skip gram bag of words. Okay, so how suppose if you see that a particular word, okay, particular word has got a meaning, what are the surrounding words for that particular, or what are the synonyms for that particular word, that we are going to understand in this continuous bag of words or skip gram bag of words, that we are skip gram model in the afternoon session. Like suppose in Hindi, prem, if you say a word prem, what are the similar words around prem? Pyar, ishq, mohabbat. So these are the different words which are having a similar word, but the context, depending on the context. But in English language, it is only one word, that is love, which depending on the context, we are going to see what is that word love means. Okay, but that is not the case. We have morphologically rich language, Indian languages, and depending on the context, we are going to have different meanings for this. Different meanings can be brought out, can be understood from that text. So that is how it can be done. That is when you're going to represent the word vector format in continuous bag of word or CBOW, and also we have skip gram model. So we can understand how it is related, and how you can do the semantic analysis of the text that can be done using this uh, mm, uh, SIBO and skip grant model. So more about this we will see in the afternoon session. Then overview of text vectorization methods. So text vectorization method, we have frequency, one-hot encoding, TF-IDF, and distributed representation, and functions which we are going to have. What is this frequency? Just counts the frequency of the terms. How many times the term is repeated? Only that it is going to find in the frequency method. It is good for it is we can have Bayesian methods wherein we can use these Bayesian models for see the frequency of occurrence of the words in the particular text. So Bayesian or Bayesian methods models can be used over this, and also the most frequent words which are also not. When you say that a particular word is more frequently occurred in a particular sentence, that doesn't mean that that word is so important. Okay, so frequent words will not give you more information. In fact, some rare words also which are occurring in the text may give lot of information. So the frequent words, even though we find that the word which are appearing many a times, which may not give which may not be so so much of information may not be present in those frequent words. Okay, and this technique wherein it just finds in this vectorization method, it just finds the frequency of words, and the occurrence of more words or the frequency of more words will not be that much informative. And what better we can do if the text is very small, we can do the Bayesian models working on this, and we can find that, suppose if you say you are giving a text script written in a large script in Kannada language, and suppose you are going to see how many times a particular word is occurring in a particular different sentences, and depending on that, those important features, only those sentences which are having these words, only that we are going to extract. So for that we can use this Bayesian models. Okay, so that is one application wherein Indian languages which can use the Bayesian models for extracting the information, important information in the text. Okay, another one is one-hot encoding. One-hot encoding binarizes the term occurrence. It either stores one for the if the word is present. If it is not present, then it is going to store 0. That is called binarizing the term in occurrences. Okay, so this works very good for the this type of information, or this word vectors can be efficiently used using neural networks. So neural networks works good with this one-hot encoding. Okay, so all words equidistance, that means all words are important. Okay, and when you say all words are important, the normalization is a very important task in this one-hot encoding. So we consider that how each word is equally distance, means each word is having equally important in this type of processing. So that is called one-hot encoding. Then we have TF-IDF. So normalizes the term frequencies across the documents. So in this we are going to see which are the important terms which are present across the documents. That term, that score we are going to take, and this method is very helpful for general purpose text processing. Okay, and this is used in many applications like recommendation systems, sentiment analysis, spam detection. All these applications are using TF-IDF scores. Okay, so moderately frequent terms may not be representative of the document topics. So we are going to see the term frequency TF-IDF scores so that it can be used for extracting the important information from the text. So that is what the TF-IDF vectorization. Then distributed representation, which is a context based. Okay, and in this the similarity plays very important. So how similar the particular document is. So that is how similar or how distributed the document is. It is a context based. Depending on the context, the word meaning will be taken into consideration to extract the information from that text. Okay, so the modeling, topic modeling or modeling is very complex. This distributed representation is a complex. This is a very important in complex relationship, like how you're going to find different relation between different documents, and a lot of processing is needed in such type of uh, uh, on this vector representation, word vector representation, and especially TensorFlow is used on this. The additional tool TensorFlow is used on these vector word vectors. Okay, so a lot of processing will be done because the information is large, and thereby the processing will be done using this TensorFlow. Okay. So what is the next topic after this word vectorization? Then we are going to see, now we have represented that in a vector form. Then we are going to process. We are going to process the text pre-process the text. Okay. So what is the pre-processing the text is? We are converting this raw data into meaningful data. Okay. So what we are thereby we are going to remove the noisy data. Okay. So suppose if you have HTML information, HTML page, so it is going to have some tags. Okay, header, or if you have header footer in your text, or if you have tags, okay, or if you have markup data, XML data, or you have punctuation information, all this data, which includes these tags or punctuation marks or markup data or headers or footers, all these are considered as noise in the text. Okay, so this noise should be removed before processing. Okay, and the first task is you have to remove the noise from the data. So the first task of text pre-processing is you have to remove the noise from the text data. Then we are going to do some analysis. Okay, we are going to divide the text into tokens. So token is the smallest unit of processing. Okay, so tokenization is to be performed on this text. So lexical analysis, that is splitting the data into smaller chunks. Okay, so smaller chunks in the sense the chunks can be sentences or phrases or words or characters. So that is called lexical analysis. So tokenization should be performed on the word vector, and so that we can find the smallest unit of processing. Okay, using this text lexical analysis. So so that is the second task which you are going to do as a pre-processing of text. The third one is normalization. So the normalization is a technique wherein we are going to see even in your machine learning algorithms or statistical data. In statistical data also, we are going to represent that information in some range, some range like 0 to 1. That information you want to keep that as a normalized form. So similarly, the normalization should also be performed on the text data. And there are two things here. One is stemming. Stemming means we are going to remove some part of the word okay, that is called stemming. Suppose going, go, okay, so ing should be removed, or goes. So pruning the information, pruning the to get the root word, and that is called stemming. So stemming is what you are going to remove the suffixes or prefixes to get the root word, and that is called stemming. Also, we have lemmatization, wherein we are going to find the root word of. Sometimes it is not possible. Say. Good, best, better. So these are the having the similarity in these words. But what is the lemma of this is a good. So in certain things, we want to get lemma of the word that can be done using lemmatization. So stemming and lemmatization are the normalization process which are to be carried over on these word vectors. Then we have some words which are repeated, but which are not giving useful information, which are not giving much of the information, and such information like I, we, going, is, or are not giving much of the information in the text, and such words are called stop words. So stop words, we should remove the stop words, okay, and we should find the rare words, and also we should find the frequent words which are occurring in the text. So stop words are those who do not contribute any information in the processing, and those are called stop words. Different languages are having different stop words, and English also has got a collection of stop words which are stored, which are declared by NLTK module. Okay, and different languages also are having stop words. Those must be removed before processing the text. So this is called normalization. Then comes the machine learning aspect. Okay, so the machine learning aspect, once we have this information, we are going to apply machine learning on this text. Okay, so the machine learning is the field wherein the computers have the capability to learn without giving without explicitly program. So like how human beings are learning, even small kids, when they are learning on their own. Okay, in the similar fashion, the machines are given depending on the data. They are learning from the data which is shown to the machine. Okay, so machine learning algorithm which learn from the data, and we do not have the task which cannot be performed writing a set of instructions in any programming language. Suppose if you are not able to get if you are not able to write a program for a particular task, then machine learning algorithms are which will do better than the conventional programming. So the machine learning has the capability to make the computers to learn without explicitly program, because in this case they see the data and thereby they learn, they extract the meaning or they extract the information from that data, and that is called machine learning. It is one of the most exciting technologies all over the world. Okay, and as the name is, it is the machine learning is the you can say it is similar to human beings, like as how human beings are having ability to learn, in the similar fashion machines are also able to learn, and that is called machine learning. And it is actively being used today, and in many places. All the tasks cannot be done using machine learning. You should see which task can be performed using machine learning, which technique is appropriate for machine for the sorry for the machine learning algorithm, which can be used for a particular data. First we have to see the data, and thereby we are going to see which algorithm is more suitable to extract the information from that data or useful information from that data. And for that, we are going to use machine learning algorithm. So there are various Python libraries for artificial intelligence and machine learning techniques. Artificial intelligence, like how we say that in artificial intelligence, we say that we are going to get some information, we are going to store that in a sentence, and these sentences you might have studied in your courses in, or you might have seen in these courses, artificial intelligence, like predicates or discrete mathematical structures, predicate, propositions, how you are going to store the information, all this information. And it is just the knowledge of which you are going to store, and making inferences of this information from this uh, predicates or propositional logic, knowledge base you are going to create, and inferencing from the knowledge base, new knowledge is stored in the knowledge base. All these comprises artificial intelligence. Now, when you have the knowledge base, the new knowledge should be updated with this. And what is that new language? Whatever the machine learning algorithm has learned, that knowledge should be stored in the knowledge base. So this artificial intelligence, this machine learning is a part of artificial intelligence, wherein it has, the machine has got the capability of learning. Only artificial intelligence is not having that capability. When you other with this machine learning capability, then the machine is having the learning capability, which is, and for this we have going to have different Python libraries. One is TensorFlow. It is an open source and freeware, and it has a math library, and which is used many machine learning applications and neural networks. So TensorFlow is a very important library, Python library we can use, since it is an open source. And then we have a Keras. Keras is especially which is used for neural networks or deep neural networks and so on. So it is a network open source library, and which runs on top of TensorFlow. Okay, so Keras is very powerful, more powerful than TensorFlow, and which runs on top of this TensorFlow. Then it has libraries called Theano and PlayML and so on. Then Theano is another Python library wherein the majority is used in fast numerical computations. It is used in fast numerical computations, and it runs on both on GPU and CPU. So then we have another library called PyTorch. It is a deep learning library which is used in applications like natural language processing, computer vision, computer graphics, okay, image processing. Especially deep learning algorithms are used on more efficiently on image processing. Okay, so this PyTorch is used, and then Scikit Learn or sklearn, we pronounce it as Scikit Learn or sklearn, is a free machine learning library which is used, which has which processes different features like supervised, and which can be the features which can the features which are extracted from the particular domain. On these features, the algorithms, the supervised algorithms or unsupervised algorithms can work on this using this sklearn. So sklearn is a popularly machine learning library which you have lot of built-in functions to perform a little bit of maths. If you know about statistical knowledge or domain knowledge, if you have, then you can use this sklearn efficiently. You need not have to build the entire code. All the ready-made tools are present in this library. So you can build the projects fast in a lesser time, and so that is the advantage of using this library. And also we have pandas. This is a Python library which performs high performance, which is used. It is having a easy to use data structures like Python library. We can store that information in a frame, and we can do different operations, statistical operations on these frames. Okay, and we can use the for data analysis, like we can find the minimum, maximum, mean of a particular column, or standard deviation, or variance, or different principal component analysis we can apply for. So different uh, built-in functions we can have, we can apply on these data when it is stored in the as a frames. So pandas is a famous Python library for providing high performance, and it is having the power of this is easy to use data structure is the power of pandas. Then we have another some other libraries called matplotlib. Okay, so it is an interactive library and cross-platform. So the library is for two-dimensional plotting. So we can have a two-dimensional plotting of information. That is, we can have the information on X and Y axis. It produces high-quality graphs, charts, and plots. Okay, so matplotlib is a very this also we are going to use in the afternoon classes. And then we are going to have another that is more famous library, that is NLTK model of framework, which is suitable for many natural language processing, like symbolic as well as statistical natural language processing in Python. And then we have another library called Seaborn. So statistical graph, or so Seaborn is used for making statistical graphs in Python, and it is built upon this matplotlib. Okay, and it is also integrated with matplotlib. Okay, so then we have NumPy. Again, when we say we can only process a large volume of information when it is represented in a vector form, or and when it is a matrix form or vector form, we can use that data. We can perform different matrix calculation, like finding inverse of a matrix, or finding rank of a matrix. Different matrix operation you can perform. Matrix that you can do using this NumPy. So it is a commonly used scientific computing, and which also this NumPy was built in by one of the scientist, MIT student, graduate student. He has built this NumPy. His name is Honolu, and he built that, and this is very powerful for calculations, scientific calculations. Okay, so and hence whenever you have ML algorithms, when you're going to make use of ML algorithms, you must be using NumPy also. Okay, so SciPy is a popular ML library with different models for optimization, linear algebra, integration, and statistics. And SciPy also, which is a again, all these should be implemented in the system to process the text. Okay, so let us have some look into this ML library, scikit-learn Python library. So in this case, we have different features, the range of features which are acting up this unsupervised algorithms and supervised algorithms, how these are working with this different category of data or different information that I have shown in this diagram. I think we have different sklearn libraries, something like some are processing regression. Again, regression, we have linear regression, multilinear regression, logic regression, and so on. And also we have classification. So classification, again, classifying the information into different categories. And then we have classification is a supervised machine learning. Then we have clustering, wherein when you say classification, the labels are attached to this information, whereas when the labels are not present and the algorithm has to extract the information by learning the data, and that is called clustering. So clustering algorithms, there are many clustering algorithms in this SQL. So K-means clustering. I had used in my research work DB-scan and DB-scan clustering, optic clustering techniques I had used. So there are different clustering methods which the packages which are present in sklearn model. Then just I have shown you what are the different, how this will look like classification, how you're going to classify different images. Then regression, with respect to a regression line, how the information is varying with respect to regression, and clustering, how the clusters are formed in that information, and dimensionality reduction, how different data, how large information you're going to have dimensionality reduction, you're going to multi-dimensional information you're going to have. So you're going to find which are the prominent dimensions which you can have in that data. That only you're going to consider, and that is called dimensionality reduction. And then we have model selection algorithms, wherein again we are going to see which algorithm is more suitable for that particular. We should apply all different algorithms for that data, and which one is best suitable, or which one gives which one will give particular more better results, more precision, or more better result or accuracy. So that model can be selected. And so some of the models are having pre-processing which can be used. So these are the different sklearn models which we can have in this. So sklearn is basically used for machine learning. It has many machine learning libraries which are present in sklearn. So this should be installed in the system. And just let us take one case study for this sentiment analysis. Like suppose we have the large documents, I'm going to show here, and this should be tokenized. So when you say you are going to have the basic building blocks of this text we are going to have, and that is called tokenization. So what we are going to do in pre-processing is pre-processing the text means we are going to remove the stop words, okay? And also we are going to remove the suffixes or prefixes, and also we are going to get the root form of that word. So that is called a pre-processing, okay? Once this is pre-processed, the text is pre-processed, then you are going to extract the features. So the feature engineering, it is also called feature engineering. So feature engineering, we have seen different techniques, that is bag of words, TF-IDF, word embedding, one-hot encoding, and so on. So depending this feature engineering, after that we are going to have the features, important features of the text, and for these important features of the text, we are going to apply the model. Okay, so we are going to build the model. We are going to see which algorithm is suitable for that, and we are going to apply that, and that model we are going to evaluate. If the performance is better, then we are going to see different models we are going to apply for these features, and we are going to evaluate these different models, okay, which are operated on that on those features, and thereby you are going to evaluate which model is suitable for a particular application, and then we are going to do the testing phase. So in the testing phase, we just give some information, and the model which has already learned, it is going to understand, and thereby giving the uh, uh, appropriate results. So that is called testing. So we are going to divide in lab, we are going to divide the text into training phase as well as testing phase. And this testing also, we are just checking that we also know in the testing phase, we also know that what is the output of that, but whether the machine is going to give, whether the algorithm is going to give the result or not, that we are going to check. Okay, so next one is what is the future of NLP in India? So there is a lot of time for make for India. So because we have many languages, and many languages, since a lot of work, we have to build corpora for different languages. We have to build NER for different languages. We have to build WordNet for different languages. And these are very important tasks which are to be performed. And we are far way to go ahead for this. Okay. So these are the different um, uh, libraries which I have made use, and material which are there for this. You can go through these. Uh, you can go through these websites to learn more about these modules. Okay, so thereby we can have some discussions regarding this. I just give half an hour for uh, finishing, because I just thought that by 12 o'clock, if I finish, then till half an hour we can have a discussion. So anybody would like to ask something? So just you can ask. So audience can ask questions.
Hello, good morning, madam.
Good morning, sir.
Data cannot be given directly in numeric form in this NLP.
Sir.
Can we create our own stories, madam?
Yes, sir. We can create, that is what we can have our own. But the thing is, the vectors will be sparse. Means most of the information will be zeros only. Okay. So some techniques wherein we can avoid such storing such large matrices. Okay. So some techniques are there that I would like to.
Actually, I watched two movies, Game
Yes.
of Thrones,
Yes, sir.
Harry Potter. It is a text-based.
Yes, sir. Yes, sir.
Okay.
Now processing speed is also not a problem, because we have GPUs, we can have, that is not a problem, but uh, optimization is very important.
Okay. Thank you.
Yes, sir.
What is
Hello. Hello.
How overstemming is different from stemming?
Stemming is what we are going to remove the like ing. Okay, the root word we are going to you want to have. Okay.
Any limitation is there in number of words?
No, sir.
Overstemming is there, madam.
Haan, sir. There are many built-in. This one also have the Porter stemmer. Many, and we can have our own stemmer can be built using regular expressions, sir. That I would like to talk in the afternoon.
Okay.
We can design our own stemmer, sir.
Okay.
We have ready-made stemmers, but we can have our own stemmers also.
Yeah, Porter stemmer,
Porter stemmer. Yes,
Lancaster stemmer.
yes, sir.
Okay.
Porter stemmers are there, and we can tailor-made. We can have tailor-made stemmers also using regular expressions, sir.
Okay.
Python. Yes, sir.
Thank you.
Okay, sir. Thanks a lot, sir, for giving me the opportunity.
Thank you very much, madam. So any participants, any more questions? One or two participants can raise. If there is no question, we will wind up the session, and session will begin afternoon 2 o'clock, sharp 2 o'clock, and just 15 minutes before you join all of the participants.
Thank you, sir.
I think there is no queries are coming up.
Okay, sir.
So afternoon session, we will join at 2
2
o'clock.
o'clock, sir. Okay, sir.
Thank you, madam, for the morning session.
Thank you, sir. Thank you.